Good morning, everyone. Welcome to today's hearing. Today we're going to continue hearing evidence from Professor Torero. So I'll ask Professor Torero to come back into the room, please. Good morning, Professor.
Good morning.
Welcome back.
Thank you.
All ready to carry on, I hope?
Yes.
Good. Thank you very much. Yes, Ms. Green.
Yes, thank you. Good morning, Professor Torero. So when we broke off yesterday, we were in the middle of discussing the system that the Queensland government implemented after the Grenfell Tower fire. I now want to turn to testing and have a look at their approach to testing. And if we could go to the Queensland submission to the inquiry again, that's a QLD 702. And I want to look at page 30 of this submission. So strategy 5 was the testing of materials, and underneath the text in bold, under testing protocols, it states this: to reflect the first principles engineering approach presented within the CPD course for fire engineers, a testing protocol was developed in association with the University of Queensland to allow fire performance to be tested at an individual material level. This approach was preferred over existing techniques such as large-scale facade testing, as it allows a fast and conservative analysis of the fire behaviour of individual cladding components based on fundamental principles. And then I also want to look at the third paragraph there. It says, ultimately, the purpose of this testing protocol was to provide the necessary material properties to quantify the external fire spread hazard presented by the combustible cladding present on a building to inform a performance solution. And then they go on. In this respect, the testing regime complements the tests previously adopted by the Queensland's regulatory system. Those are AS 15301, 15303 and 5113, while providing a cost-effective solution to the issue of product substitution, which has resulted in significant loss of confidence in the as-approved documentation of a building. So that's what's said in the Queensland submission. So does this mean that, at least initially, Queensland decided to fundamentally change its approach to the testing of construction products?
That is correct.
And can you just help with, right in the first line that I read, it says to reflect the first principles engineering approach presented within the CPD course. Can you just help, what does that mean?
Yes, so there is the Queensland government clearly recognized that there were two problems at hand. One of them was to identify the risk of existing buildings, and the other one was to provide solutions to these buildings. Now, the identification of risks got quite complicated because there was a very rapid realization that while many materials were labeled in a certain way, there were minor changes in composition, and those minor changes in composition many times have a significant change in fire performance. And therefore, it was first important to be able to identify what these materials that already existed in buildings were, and that required quite an extensive protocol of material testing that used a number of state-of-the-art equipment that enabled to characterize these materials so that we at least had a good understanding of what was on these buildings. Now, the information that was extracted from that material testing complemented with a number of ad hoc flammability tests that were being conducted at a small scale at the University of Queensland, provided information very much in line with my presentation, the values of phi, thermal inertia, ignition temperatures, all these different things, as well as establishing, as Professor Bisbee described, mechanisms of failure for these different types of materials. So it provided fundamental first principles information for practitioners who had been educated through this CPD process to be able to do some level of quantification of the risk that these buildings imposed. Now, obviously, in the Australian system, given that we do not have a stay-put strategy, but instead there was a possibility of different levels of evacuation. The focus was obviously on quantifying the potential for fire spread. And so the fire spread velocity was the key target of this first principles analysis, enabling the engineers to actually establish, the fire spread velocity and the extent of the potential damage and involvement of the rest of the building that was possible. But the intention was to deliver a holistic analysis, so they could actually analyze the full impact of having a fire, and on the basis of that be able to propose solutions that not only were effective at delivering an adequate fire safety strategy, but also they would potentially be much more cost effective than just completely removing, for example, everything from a building just because it didn't meet some simple criteria of combustibility.
Yes, thank you. That's very helpful. So just to be clear, those tests that are described in that last paragraph I read on the page, the AS 1530, etc. tests, now they're similar, aren't they, in terms of some of our national small-scale tests, and also the AS 5113 is similar to the BS 8414 test, is that right?
Yes, so AS 5114 was adopted after the Docklands fire, and is basically a version of 8414, is almost identical. And 1530.1 and 1530.3 are your non-combustibility tests, very similar to the tests that we have in the UK.
Yeah, so similar to the 476 Part 4 test
Yes.
that we have in the UK. And I think what you've just described is that what they did is take those tests that they'd used for a while and then supplement them with additional tests which provided data for the crucial fire performance metrics that you need to be able to assess an external wall system.
Exactly.
Yeah. And how successful was that system while it was operating?
Well, I mean, it's difficult to describe a metric of success other than the fact that the system was implemented, and the CPD courses happened, and people were asked to provide the materials in their buildings, so that the University of Queensland will make the assessment and publish all those materials openly in the materials library. And the government paid for the tests, and everybody volunteered their materials, and therefore the library is populated with, I think, several hundred different types of products right now. And many people have used the data of the library, not only in conducting assessments for performance, but also particularly to try to identify the specific products. So in that sense, I think the approach was extremely successful. Now, when it came to the actual practice of conducting these risk assessments, then it's much more difficult to establish success, because obviously there are certain practitioners who embraced the CPD, educated themselves to an appropriate level, and started delivering an appropriate service. And I believe many of them were very, very successful at demonstrating appropriate schemes that enabled to have much safer buildings. But in that sense, that more or less never got fully resolved, because it never became mandated that these individuals who were accredited according to this process will be the only ones who actually could do that. And I think what ended up happening is that the system started being used by people who did not have necessarily the competency, and it's not very clear exactly where we are right now.
Yes, I understand. And I'm going to ask you a little bit more about the cladding materials library, which you began to explain just then in more detail in a moment. But just pausing there, what was the role of the large-scale testing within that first principles engineering approach? Was it just to validate, check conclusions that had already been reached by applying the results from smaller scale testing, or what was known about the materials?
That was potentially the case. I think in many cases it was just a validation. So you will have, as part of the process, people will actually predict the spread rates in the test. Now, the test has a very, very coarse estimate of the spread rate, in the sense that you only have 2 points to calculate how fast it spread. But nevertheless, you have videos and you have other information. So many people actually use the tests as a mechanism to validate the analysis that they were making. Now, other people use those tests also for additional information. So one of the good things that this approach did is that it encouraged practitioners to actually interrogate the information that they had from the test in a much more thorough way. So instead of just taking a very simple pass-fail criteria, and when I say pass-fail criteria, I don't mean that there is a pass. It's just a binary line that says you failed. And but taking this sort of binary criteria, which is the approach that we have taken in the UK, instead what people did was interrogate the test. So they were looking at photographs of the aftermath. They were trying to, in tests that were conducted later, they were interrogating the debris, because in many ways what they had to do is gain comfort that the calculations that we're making, were in many ways supplemented and validated by the test.
Yes, I understand. Does that mean that it had more instrumentation on the rig compared to what we would see with an 8414 test?
That is a very interesting point that you make, because I have heard of numerous cases where the practitioners required much more instrumentation and also required modifications to the test. So, for example, something that was done several times was there were certain buildings that had very minor areas with these types of materials. And the practitioners requested a number of different tests where different options were tested of what to remove, what not to remove, in such a way that they would create fire breaks, for example. So yes, I mean, it really, as I say, it really encouraged practitioners to push the bounds of the test beyond what the standard required.
Yes, so to make those large-scale tests more bespoke, depending on the phenomenon you thought you might get and that you needed to validate. Is that fair?
Exactly.
Yeah. So we know that Queensland established this cladding materials library. It's available for anybody to log into.
Yes.
You register, don't you? And you can get a login easily and look at the library. So I've done it. Anyone can do it, yes?
Yes.
Let's go over to page 31 of this submission, where we see that cladding materials library explained in more detail. We can see there that they say, using the testing protocol developed by the University of Queensland, the Queensland Government supported investment in the necessary specialist equipment, staff and product samples to establish a database or cladding materials library. The data will assist competent fire engineers in assessing the fire hazards of cladding materials on existing buildings. DHPW developed a methodology for sourcing and cataloguing hundreds of product samples taken from government-owned buildings. To overcome the challenge of unknown products and product substitution, a sample collection strategy was developed with a range of samples required for testing. It's largely based on the building grouping assessment. And then so they tested according to different categories. And I think what they're saying there is, with a high-rise building, for validation reasons, they require a minimum of 10 samples and up to 15 samples to check that what they were sampling was consistent. Is that correct?
Yes, it was an issue of consistency. The bigger the building, the more the surface area, so you have to get more samples to make sure that certain parts of the building were not cladded with different materials than other parts of the building.
Yes. And if we go back to your report and what you say about this in your report, this is at JTOR 706, page 189. And at paragraph A216, you say this. You say, the most extensive among all these studies is the University of Queensland Cladding Materials Library. This work was part of a comprehensive programme funded by the State of Queensland that aimed to address the assessment of risk posed by combustible cladding materials. The library followed a rigorous methodology that first provided methods of identification of the different components of facade systems. These methods used state-of-the-art diagnostics, including many of the diagnostics used by McKenna et al. The identification of the material was followed by a comprehensive set of small-scale flammability tests with the aim of extracting all relevant flammability properties. The properties aimed to enable engineers to use this information in models that could serve to predict the risk imposed by different materials used in facade systems. A series of tests aimed at providing further data in support of these models was also proposed. For this purpose, a professional development programme was designed to ensure that professionals conducting risk assessments had adequate competency to conduct these analyses. The professional development programme was assessed by means of examination and a certificate provided by the University of Queensland. And I think you can confirm when you go to the online library and you put in a product such as PIR insulation, you get a very significant quantity of information provided in graphs, diagrams, tables that goes for some way down the page, giving you all sorts of information about the flammability properties. That's right, isn't it?
Yes, you will get a very extensive amount of information, and also you will get a number of variants. So the PIR, there's many versions of PIR, so you will see the different versions of PIR that were submitted, and you can see the differences between the different products. Many of those actually will be sometimes labeled with the same product name, and nevertheless they're distinctively different.
Yeah. So presumably that did require the cooperation. Did manufacturers buy into this process as well and submit their materials, or was it just come from government buildings?
It mostly came from government buildings. I am not aware of any manufacturers volunteering their products, but I'm not 100% sure. I didn't follow every single one of the products that got submitted.
Yeah. And we saw there that you said it's about 6 lines up, that a series of tests aimed at providing further data in support of these models was also proposed. Do we take it from that those series of tests didn't end up being carried out?
Yes, the approach that the program intended to follow was that if you rely on the very basic material data that enabled you just to identify the product and use the data that was collected for that specific product, then the decision-making process when it came to the way in which you addressed the performance of the fire safety strategy had to be enormously conservative. So that was the principle. Now, if you progressed to incorporate an analysis that included a lot of the flammability variables with the small-scale tests that were more fire type of tests, and you could quantify things in a slightly more precise manner, that enable you to be slightly less conservative but remain within the bounds of appropriate safety. Now, the idea was that the next level was to move to more of a system performance, where you actually had intermediate scale tests very similar to the ones that Professor Bisbee described. And then you will have understood better many of the failure modes, and that will allow the engineer to make an even more informed decision that potentially will open the door for even a broader range of materials, and the ultimate goal was to conduct a number of validation large-scale tests to actually demonstrate all these forms of behavior. Now, the latter 2 stages never happened because that's where the program stopped.
Right, yeah. And can you explain why that program stopped?
I think in essence, it's the very common conflict that happens when you get opposing opinions. That somebody at the end has to anoint the expert. In this particular case, it was the minister. And the minister got a lot of pressure from a number of different spaces, and they effectively, because they recognized that the process proposed by the University of Queensland was a long and significant process, that got weighted in the decision of making, of listening to different parties. And then at the end, the decision was to stop where they were, not go any further, and allow the market to decide what was going to happen under the constraints of a very simple ban, just like New South Wales and Victoria has done.
Yeah. If you were designing an idealized testing system, would you say that ought to involve taking something like the Queensland data and taking it through to system level, so that you then would have a database which covered individual material performance, product performance, and then system performance?
Yes, I mean, it's no secret that I, to some extent, was involved in this process, and I had already left University of Queensland, but I have a close relationship with the people that are there. So this model is very consistent, with my way of thinking. So I think if you look at the sort of the range of conformity levels that I put in my diagram in the report and that we discussed during my presentation. I think one of the things that we need to recognize is that if we are a manufacturer and we don't provide any relevant information, then the onus is on the later stages. So we're passing the problem to the later stage. And of course, because we're throwing different products and those products are unqualified, unquantified, uncharacterized, then the complexity of the job of those who come next, the designers and the people who are constructing and implementing the building, is obviously extremely high, extremely complicated, and requires a level of competency that is extraordinary. But if I responsibly take my own product, and I developed it, characterized, do all this background work that is in the materials library, and provide all the information that allows the engineers to confidently make an appropriate assessment, I have, by doing so, reduced the onus on the later stages of the process and enabled these engineers to actually operate in an efficient and safe manner without necessarily having to understand the whole chain of competency that goes from polymer chemistry, all the way into the thermomechanical behavior of an encapsulation system. So every part of the chain has a responsibility to take part of the knowledge because it's extremely broad in nature. It's a very multidisciplinary problem. So if I was a product manufacturer, I will make sure that I fully characterize to as much as I am capable the product so that I deliver to the next stage of the design process something that already has a great certainty that I do understand the behavior, the failure modes, and so forth.
Yeah. But I suppose that might depend on whether they're producing a single product or some kind of system which then is for use in the market. If they're producing a whole cladding system and selling that, that's one thing. But if they're just producing an individual product, doesn't any competent system or good system still need to have people further down the chain that can make an assessment of system performance?
Of course they do. I mean, I think it is just where you hand over the baton. I mean, that's the whole thing. No? It's if you are just the material manufacturer, then you're going to characterize the material as a material.
Yeah.
And if you're going to pass it on to a product manufacturer that then is going to include an encapsulation, then it is the product manufacturer that should be characterizing the encapsulation, taking into consideration the potential applications of the product. They're going to market a product with a functionality.
Yes.
And because they're marketing a product with a functionality for a specific type of application, then they should understand, for example, the failure modes of the encapsulation. Now, obviously, then the organization that is going to assemble it into a cassette, and now they're going to include several materials, and they're going to include an geometrical arrangement, fixations, and so forth. Then it is the onus on them on characterizing how that system behavior operates. And then that's going to be put in a building. And then it is the designer of the building that should take all this information and make sure that it works with that building, and take into consideration height and use of the building. And so we go through the chain. Now, the question is at which stage each individual group hands over the responsibility and what information they're required to provide. Yeah. If we don't provide anything from the beginning and we let the whole process go all the way till the end, then those people who are actually designing and implementing the building have to take the full responsibility over an extraordinary wide range of competencies. And that is not possible because, you will need a Renaissance man to be able to do that. So at some point, the baton needs to be handed.
Yes.
And it has to be done in a responsible way.
Yes, I understand. So I think what you're saying is if you were the manufacturer of an ACM composite material product, 2 skins of aluminium with a PE core, there's actually quite a lot the manufacturer could do to faithfully explain its performance in fire and the potential ways that the encapsulation by the aluminium can fail with different fixing systems that then would really inform those at the next stage of the process, even if that's then going to be used perhaps with an insulant in a system.
Absolutely, and I think that was the principle behind the materials library. It was that stage, more or less, that brings you to what we assume is the responsibility of the manufacturer So it brings you to that level. That's where it stopped.
Yeah. But would it be possible for somebody to pick up that data and keep moving forward with it?
And that's what the CPD was for. So the CPD was to enable engineers to pick up that data and be able to actually do the fire engineering, and deliver an adequate holistic fire safety strategy.
Yeah, thank you. And just to be clear, I think you touched on it earlier, in terms of the assumption in Queensland, and indeed across Australia more generally, what's their approach to stay put versus evacuation or phased evacuation strategies?
Yeah, as I indicated yesterday, I think in general the conventional approach will be a phased evacuation strategy, and therefore the focus in this particular case was the rate of flame spread.
Yeah, so that's what they were trying to measure with all this data.
Yes.
To check that time was less than the time to evacuate.
Exactly.
Yeah. And I think, as you've already touched upon, Queensland has recently abandoned that holistic system and has gone to more blunter tools in terms of dealing with the cladding system. Is that right?
Yes. I mean, I think it's not that they have abandoned it, it's just they stopped enforcing it.
Yeah.
And by doing so, it was equivalent, to abandon it, because the simpler approaches became more the norm, I believe.
Yes. And you've given some reasons why different aspects of the model didn't end up finding favour and didn't get the enforcement behind it that was perhaps originally intended. Can you just summarise for us the key reasons why this system didn't succeed?
I think the fundamental reason was that there was a perception that one, it was going to take too long to be able to put all this machine in place, and there was a pressing need for much faster answers. And because keep in mind that if you follow this process, you have to do a very thorough analysis of every building. And that very thorough analysis brings a cost and it brings time. So I think the cost and the time, was clearly a very significant variable on it. And I think, I want to repeat that I think the other one is the uncertainty of who's right. I think that in a space where professional practice is not clearly defined, there will always be two parties, and at least that are going to argue what if the solution is appropriate. So what you saw was a lot of conflict. So you will have an engineer that will apply all these first principles, that will take all this and embrace this knowledge and propose a solution. And obviously that solution carried a very significant cost. Now then you go into litigation, there will be another engineer that will say that's not necessary.
Can I just intervene here? I'd like just to go back a little bit to what you were saying about manufacturers providing information about the behaviour of their products. And I can see the force of the suggestion that if they do that, then the designers and so on have something reliable to work on. Does what you suggest envisage that there should be some legally binding requirement on manufacturers to test for certain types of properties and to publish the results?
It's a very interesting question. I think from my perspective, legally binding can be in numerous different places, and I think that when it comes to safety, you actually do need that legally binding requirement that is placed on whatever entity is putting forward a product. Now, that legally binding requirement doesn't necessarily have to be met as a matter of compliance or as a matter of delivering safety, but it could be a legally binding requirement to report a list of information that pertains to that material. Yeah. So the issue of conformity, from my perspective, is what it is important. If you require a minimum amount of information to be published on that material openly, and for those manufacturers who are selling the products to actually be open to accepting people analyzing those for conformity, the equivalent of a label, no? And I think that to me is something that I believe is fundamental, because nobody knows better than the manufacturer what they are producing, and safety is a functionality, so they have to be accountable for that functionality that they're providing.
No, that's helpful. Thank you very much. Thank you, Ms. Grange.
Yes, thank you. Just one last question about the Queensland system, or indeed Australia more generally. Has anyone grappled in any detail with the problem of those with disabilities, with mobility problems? Was that something that was ever addressed as part of the Queensland system?
Absolutely. I mean, I think the moment that you put forward a holistic fire safety strategy, and particularly if you're going to rely on an egress strategy, there has to be a consideration and appropriate provisions with everybody that can actually enter the building. And so clearly, this type of approach enables you to assess carefully what will be the performance of the building in regards to the integrity of the population. And so it doesn't become an assumption, that people can stay and it will be fine. It becomes an explicit analysis that shows that people can stay and they will be fine. And I think that had to be taken into consideration. So the fact that most people will evacuate doesn't necessarily prevent creating a safe space for a smaller number of people that actually will have to remain within the building.
So does that basically mean things like refuges?
That's an example. That's,
yeah.
For example, a way to do it, yes.
Yeah. So because you've got an egress strategy, you've got to think about whether these people are going to stay. If they're going to stay, where is that going to be safe? If not, how long is it going to take them to evacuate or use a lift or whatever? Is that the point?
Yeah. So proactively, you put all the necessary provisions and you make explicit how those provisions are going to work. It is about. To be honest with you, for me, it is really more about having a plan and demonstrating that that plan works. And because you're addressing a fraction of the population, then that plan is going to require resources that are commensurate, to the expectation that you have of what fraction of the population of the building is going to be required that type of support.
Yeah, thank you. So I now want to turn back to some perhaps quite detailed questions about the current UK regulatory approach to testing. Now, in your presentation, and you've touched on it again this morning, you identified these key performance metrics, which are, in your opinion, key in terms of assessing external flame spread, including ignition, flame spread, extinction, and thermomechanical performance. And you highlighted the need to quantify heating length and flame spread velocity as key parameters, which may be particularly important in order to understand whether particular fire safety strategies are going to work or not.
Yes.
Now, in your report, what you've done as well is you've analysed some reaction to fire tests that have been used in the UK, and you've critiqued them essentially. And I just want to start with just a few questions, because you've covered it in detail in your report, about the BS 476 testing regime. And I want to ask you about BS 476 Part 6 and Part 7. So Part 6 we know is the fire propagation test. And if we can see a copy of this standard at CTAR 6016. There we have it. It's the method of test for fire propagation for products. And if we go to a diagram of the test, which appears at page 13, this is a diagram, I think, of the rear of the test, just to remind us what the apparatus looks like for it. And just to recap, it's that chimney at the top which records temperatures of the gases leaving the chamber. Is that right?
Yes.
And the output of this test is expressed as a fire propagation index, which is established by measuring the temperature in the gases in the chimney of, on the one hand, a calibrated sample, and then on the other hand, several specimen samples. Is that your understanding?
Yes, that's correct.
Now, does fire propagation index, does that have any correlation to real-world fire performance?
Not in itself. I think that obviously the measurement that you're making is a thermocouple measurement, so you're measuring a temperature increase, and the temperature increase is directly related, given the condition of the test, to the combustion that has occurred on the inside of the chamber. And in as such, you can take that information and extract the heat of combustion. And the heat of combustion is one of the parameters that governs flame spread. So in principle, you're getting one component, of the whole picture, and but still requires analyzing the information of the test to extract the variable. The index in itself, it is fundamentally an arbitrary index that sets certain thresholds, and those thresholds are indicative, but they are not related to the physics of the problem.
Yeah. And is it possible to establish the thermal exposure of the sample?
Well, not with the test as designed. And the only thing that you can establish is that you're under conditions that normally will ignite most materials. And but as the test is utilized, you will have to instrument it much more heavily to be able to get some sense and characterize the thermal exposure.
Does that mean that it's quite difficult to relate the performance of this sample in this particular test with any particular design scenario?
It limits the information you can take. So you know that at those temperatures it will ignite. So if the material is combustible, it will ignite, and it will give you a sense of how much heat releases in the process of ignition. But so in many ways, it limits what you can get purely to just that heat of combustion after an analysis. You cannot get any further information. So for example, the moment that is defined as a propagation apparatus, it really doesn't tell you anything about how fire propagates. Because since you don't know what the external heat flux is, the exposure, the propagation is just arbitrary and is just purely dependent on the test itself. So I wouldn't rely on anything associated to propagation. All that I can get a sense of is, and for me, more than the index is from the thermocouples, is how much heat these materials are capable of releasing.
Yes, thank you. That's very helpful. And then moving on to the BS 476 Part 7 test. That's the method of test to determine the classification of the surface spread of flame of products. We've got a picture of this test being performed in your report. If we could go to that, JTOR 706, page 131. It's figure 20 at the top of the page. So that is a picture of that test being performed. So we've got the radiant panel to the left and then the sample held in its frame on the right, yes?
Yes.
And we can see there that a flame is progressing horizontally across that panel, and there's various lines we can see which are various parameters that are being tested, yes?
Yes.
Now, so is it right that essentially this test measures whether and how fast a flame spreads laterally across a product? Is
Yes,
that correct?
That's correct.
Does it tell us anything value about ignition?
You could treat the data and extract an ignition temperature out of it. So the North American version of this, which is ASTM E1321, basically is fundamentally the same test, but it incorporates a methodology of data analysis. And that methodology of data analysis is much more thorough than the British test, and it allows you to extract out of the results of the test an ignition temperature. So it could potentially give you information about ignition if analyzed correctly, but if used the way in which the standard describes, that information is never extracted.
Right, yes. And does it tell you anything about the propensity for vertical flame spread?
Again, so there is, I explained this parameter phi, that represents the amount of energy and the heating length. And that value of phi can be extracted for the test, and that value of phi will correspond only to lateral spread. Now, I could analyze this using a much more complex approach and try to change the interpretation of phi so that I can get relevant information that could potentially allow me to extrapolate these results to vertical fire spread. But without that detailed analysis, and that is a complicated analysis because you have to reanalyze the flow structure and transform completely the way in which the heat from the flame goes to the material. And you can bring it back and extract something, but then it will have to be caveated by a big error bar because that extrapolation is not trivial.
Yes, I understand. And I think in your report you refer to studies of European tests which correspond with BS 476 Part 7, which in fact give very different results for the same materials. Is that right? Yes.
I mean, what ends up happening is that a lot of these tests, because they're run under different conditions, and those conditions are not characterized appropriately, and in principle, the measurements and the results are extremely simplistic, and the analysis method is extremely simplistic. Every test is going to change some variables, and you're going to get a slightly different answer. And therefore, what you get is what appears to be conflicting classifications, but really what it is that we're running tests in the blind. And so we're really just running a test and getting some indicative values, but those values are not directly linked to the fundamental parameters, and therefore, it is extremely difficult to compare this test. You will get very contradictory results.
Right. So you could run 5 tests on the same product and get wildly varying results. Is that what you're saying?
Yes. I mean, there's a famous study by Howard Emmons, which is a professor at Harvard, from the 1970s, where he takes all these tests and he explains how you can actually run a fire spread test around the world on the different standards and basically get results in all directions. And but in essence, I think the point that I want to emphasize it is not the test itself, it is the way in which we use them. That we are not really extracting the fundamental information. What we're doing is trying to get a simplistic output without considering the complexity and all the variables that are associated to the test. I could use this test and do a proper analysis and actually get some information from the data, make the right measurements, and that information, if I was to do a different test and do the same level of highly sophisticated analysis, and I will probably get the same fundamental parameters.
Yes. Can you comment then on the appropriateness of using those 2 tests? We've seen that in our system, or certainly in the guidance in Approved Document B, that the combination of these 2 tests was used to get, for example, National Class Naught. Can you comment on the appropriateness of using those tests in the way they were used, so not the detailed analysis you're talking about, to assess external fire performance?
It's highly inappropriate. I mean, it doesn't represent the full set of parameters. It's too simplistic of an analysis, and particularly is highly inappropriate when it comes to the assessment of products that are composed of more than one material, because the composite form of behavior is one that, for example, this particular test provides absolutely no information because it's a surface flame spread test. So it is only the exposed material that becomes relevant, and whatever is happening behind that really doesn't materialize in the test. So in general, I think these tests are used, the way in which they're used is too simplistic for the types of materials that we're talking about. So it's highly inappropriate.
Yeah. And another point that you make in your report is that radiant panel that we see there imposes a heat flux of between 5 and 32.5 kilowatts per metre squared. But as you've said, and as we've referred to many times, external fires in buildings can impose a heat flux of something like 120 kilowatts per metre squared.
Exactly, which fundamentally disqualifies this test as a scenario test. Because it doesn't represent the scenario. So even if you want to say, well, because it worked like this here, it will work the same way there, that not even that is possible, because from the perspective of a scenario test, it's completely disqualified by the fact that it introduces a much lower heat flux.
Yeah. And so in summary, is this fair? What you say in your report is that these tests actually don't provide some certain types of key information, certainly in the simplistic way in which they're run and reported on in the UK, about the key parameters that you need to assess external flame spread.
That is correct.
And And in fact, they weren't intended to do that. That was never their intention.
No, they were never intended.
And it's therefore always going to have been necessary, although people might not have appreciated it, for the competent professional to take the data from these tests and very carefully analyse it to see what it's actually telling you and what it's not telling you. Is that fair?
Yeah, that's absolutely correct. And there is one additional step to that. I think it is to the competent professional, like, for example, in the case of an ACM, to be able to recognize that this test doesn't provide any information at all on the performance of an aluminum composite panel. So I think the responsibility from my perspective of a competent professional is not only knowing how to interpret the data appropriately, but also it is a responsibility to be able to disqualify the use of certain tests that are highly inappropriate for a specific product.
Yes. So I now want to ask you some questions about the European reaction to fire classification and testing regime. And we know that there's an overarching classification system, BSEN 13501, Part 1. If we look at page 138 within this report, at figure 22, we can just remind ourselves of the list of classifications that the European system uses. And in those columns, we can see, for example, that often a particular classification is achieved only by a combination of tests. That's right, isn't it?
Yes.
So A1 is achieved by a combination of the EN ISO 1182 test and the EN ISO 1716 test. And this is a single classification system, isn't it, that's applied in Europe? But is it right, and I think you make the point in your report, that it's attempting to capture a very broad range of physical phenomena relevant to fire, and they're trying to achieve it by the broad range and complexity of the resulting testing protocols? Is that a fair description?
Yes, that is correct. I think this test is a very good example that illustrates what is behind the definition of a test. And if you don't mind, I would like to take a step back and compare the physics of what this test is intending to describe.
Do you mean particularly the SBI, the single burning item test?
Yes, the single burning item test, which in many ways also describes the room corner test.
Yes, let's look at a diagram of that. So at page 149 of your report. So we know that this SBI test is critical to the classifications for many of these classifications, B to D and then A2. And just by way of background, you tell us in your report that all the other tests that go to the classification system already existed or were adapted from existing tests. But EN 13823, this single burning item test, was specifically created to fill a gap in the data. Is that correct?
Yes, the single burning item was created to reduce the scale of a phenomena to a level where it was still appropriate.
Yes.
So that the test could be run faster and cheaper than a full compartment, which is the room corner test.
Yes. So I think it's right to say, isn't it, that it's based on a test called the room corner test. That was ISO 9705.
Yes.
Is that right? And was that a large-scale test?
Yes.
And the single burning item test uses the same reference scenario as that room corner test. Is that right?
Yes.
And so here we have a diagram. Do you want to just explain to us the difference in terms of the physics of what this test is measuring compared to the physics of what you need to look at for external wall performance?
Yes. So this is a very, very good example because I think in many ways illustrates how we sometimes miss the nuances. So if you think about the purpose of this test, the purpose of this test is to try to establish how much time people have available when they are in a compartment where a fire starts. And the sort of reference event that is used is flashover. So you know that when you reach flashover, then conditions in that room will be completely untenable. And therefore, by making sure that everybody has evacuated that room way before flashover has happened, you can have a measure of safety. That is the basic principle. So what this test does is it basically looks at flashover, or the time to flashover, as the mechanism that is going to be used to classify wall linings. And so it is designed originally for the purpose of assessing wall linings, and it's looking at a phenomena that is specific, which is the time to attain flashover. So the process until you get to flashover goes from the origin of the fire until the moment you attain flashover by compromising the linings. That's the idea. So the initial fire, the initiation fire, is very small because you're at the very early stages of the fire and the compartment in itself is cool. So what you want is to make sure first is that that initiation event is consistent with a typical scenario. So this is equivalent to a waste paper basket.
Yeah.
The next step is you want to put that in a position in which it is in the worst possible position, which is you put it in the corner. Why do you put it in the corner? Because it compromises two walls. So very rapidly it's doubling the role of the lining. So you're putting it in a worst case scenario, and you have an ignition source that is consistent. Now that ignition source is extremely small. And in the room corner test is 100 kilowatts and 300 kilowatts a little bit later. And in the SPI is approximately 30 kilowatts. So it's a very, very, very small ignition source, very consistent with the experiments that Professor Bisbee did. So it's a very, very small ignition source. Now, the entire compartment is cold. So there is no extra energy coming from anywhere. It's a compartment. It's only the linings that are going to ignite, and they're going to start spreading a flame. Now, here you have a flame spread process. And that flame spread process, as it grows, what matters is how rapidly it grows, because that's what creates a smoke layer that is going to descend. It also matters how much energy is releasing, thus you need to measure the heat release rate, because that energy is going to be deposited in the smoke layer and increases temperature. Another thing that is going to matter is how much soot or how dense your smoke is, because that increases the emissivity of the smoke and increases the heat feedback to the linings and thus accelerate the spread, bringing you faster to flashover. This is why you have the FIGRA and the SMOKRA as the two indicators of performance, because you want to know how dense the smoke is, your SMOKRA, and you want to know how fast your fire spreads, that's your FIGRA. And your heat release rate is the third indicator, and together all those enable you to assess how that smoke layer grows, because it is the radiation from the smoke layer that will bring you to flashover.
Yes.
So what you're assessing in this test is purely how that smoke layer is evolving and is affecting the spread of a fire. So the material creates the heat that develops the smoke layer, and the smoke layer accelerates the progression of the fire to flashover. That is the mechanism.
Yes.
Okay, so it's in many ways, all these things are then put in a box, shaken, and turned into classifications. And that's the FIGRA, the SMOKRA, and all these things lead to the A, B, C, D, E classification, and is intimately linked to flashover. Now, if you tell me, let's take all the measurements of the SPI, let's break down all the information from the SPI, I could extract the heat of combustion, I could extract flame spread rates, I could extract ignition temperatures, I could extract all this different information that I could effectively use to try to assess external fire spread. But if you tell me then, instead, can you use that classification? The answer will be absolutely not. There's no problem with the test and the information I can extract from the test. The problem is me then using a classification that is intended to address a smoke layer into a problem that has nothing to do with the smoke layer, because the smoke is going away. So in the case of the external flame spread, you're not going to have a small ignition source. You're going to have a post-flashover flame plume that is going to impinge, which brings you to 100 kilowatts per meter square at least, while here you never get more than 30 or 35. So the scenario is completely different. The corner configuration is meaningless, because what you're going to have is a spill plume. And you have a whole series of other parameters that you need to consider, like, for example, the preheating length and all these things that are to some extent irrelevant here because you're focusing, in this particular case, on the development of the smoke layer. So if I want to use the information and do a thorough analysis of this test and extract all the parameters, I could probably get 4, 5 out of the 10 parameters that I need for vertical spread. But if you ask me to transpose that classification, that would not be possible.
Yes, thank you. That's very clear. So it's providing useful data. So it's not a useless test. It's useful data that you can extract key parameters from.
Exactly.
But I think what you're saying is the problem comes when you try and take a classification that's fundamentally based on different parameters and apply that classification to an external wall situation.
Exactly.
That's unreliable. Is that what you're saying?
Yeah, it's beyond unreliable. It's just incorrect and incomplete, and so it just simply cannot be done. The problem is extrapolating a classification without any further analysis. It's not possible.
So does that mean that in the approved document where we saw in diagram 40 that it could be a class 0 or a B, that you would say it's entirely inappropriate to start putting those European classifications into that kind of guidance on external wall spread?
Yeah, it's wholly inappropriate in as much as class 0 is inappropriate. So the two of them are inappropriate.
Yeah.
There's no equivalency between them, and neither of the two represents the physics that you want to analyze.
Yes. And if we look at your report at page 152, just where you summarise some of this for us, at paragraph 12.4.81, you say here, so you say this is very important because this value is much smaller than that which an external fire plume will impose. So you're talking about the 30 to 40 kilowatts per metre squared that's imposed in the SBI test. So because this value is much smaller than that which an external fire plume will impose on a facade for the scenario of relevance, which is greater than 100 kilowatts per metre squared, therefore a poor performance in the SBI can equate to a poor performance in the event of external fire, but not the opposite. A good performance in the SBI could still result in an inadequate performance in an external fire. So I think what you're saying is it can tell you what might not be appropriate quite clearly, but just because something's got a B or even, well, I'll ask you about A1 and A2 in a moment, but just something's got a B, let's say, I think what you're saying is that doesn't equate to good performance in an external fire spread situation.
Yeah, I mean, this is quite complicated because, I mean, first of all, the 100 kilowatts per meter square as opposed to the 30 to 40 kilowatts per meter square disqualifies the SBI as a scenario test. So that's the first step. Now, the second step is in both cases, now you are at a scale where there are going to be some form of system behavior, because you're going to have now products you could actually put almost a cassette, for example, in the SBI. So there are elements, for example, like mechanical behavior, the thermomechanical behavior, that if you put 100 kilowatts, you will induce certain failure modes of the encapsulation, for example, that will fail at 100 kilowatts, but will never fail at 30. So in many ways, you can your encapsulation can work beautifully in the SBI, but the moment that you have this applied in an external facade and you get a post-flashover fire that imposes 100 kilowatts, your encapsulation fails. And the problem is you are completely blind into what gets exposed. So if you're relying fully on encapsulation, what is happening is that what is exposed at that point is completely unnoticed by the test. So if the encapsulation fails and you have polyethylene in the back, or you have expanded polystyrene, for example, in the back, this will immediately burn vigorously and become a very significant hazard. You will not notice that in the SBI because the SBI does not allow the encapsulation to fail. But when you transpose the scenario, then you will have that failure, and the result could be an enormous amount of heat being released instantaneously.
Yes. But I think what you're saying is, as well, is that, but if you did your SBI on your aluminium composite cassettes with PE, and in that SBI test, it performs badly with those lower heat fluxes, and in that situation, then you certainly should be thinking it's not going to perform well with an external fire.
No, because the scenario is more onerous in nature. So yes, I mean, so if it performs really badly on the SBI, I will have to think that it will perform even worse under real conditions.
Yes.
But if you manage to create a system that performs well because it is protected mechanically and so forth, I have no guarantee that once I change the scenario, that is going to be still the case.
Yeah. So just to be clear, in your opinion, if you ran the SBI on cassettes, ACM PE cassettes, and you're getting an E or even a fail because you can't classify it,
that's bad.
That's bad. And it would be very difficult to then try and say that in an external wall
it's going to be better.
It would perform better.
Yeah, it won't.
Now, if we could just look at page 152 of your report, paragraph 12.4.86. Yes, so it's at the bottom of that page. So this is where you're reinforcing the point. You say the one aspect of the test that cannot be used are the classifications emerging from the SBI test. The classifications are based on specific measurements obtained during testing. These are mostly physical measurements such as temperature rises in the duct, which intend to represent the contribution of the sample to the overall heat release rate. And if you go on to page 153, 12.4.90, you say this, you say, given the significant differences between the reference scenarios for external facade fires and the SBI, the test-specific nature of the parameters measured to define the classifications, the lack of direct correspondence of the parameters measured to the flame velocity and heating length, and the abstract nature of some of the parameters like the FIGRA, it's clear that the classifications resulting from the test have no relevance or meaning when addressing the performance of facade systems. And is that something that you consider should have been appreciated within this jurisdiction at a time when they were doing their transposition?
Absolutely. I mean, I think needless to say, this knowledge has existed for 30 years.
So this is not a difficult conclusion to reach, that it has no relevance to the scenario.
No.
And if we also look at page 155. If we look at paragraphs 12.5.10 and 12.5.11, so you make the same point about the scenarios being different at 12.5.10, and then at 12.5.11 you say, it's therefore my opinion that any class B to F classification through the European reaction to fire protocols should not be stated in the approved documents or building regulations as providing a demonstration of adequate compliant performance of an external wall system or product used for this purpose. Now, what about the A1 or A2 classifications? We know that they require slightly different tests, as well as the SBI. Does it follow that you'd also have concerns about those?
Well, I mean, direct extrapolation to some extent, yes, because there's an element of arbitrary threshold of what non-combustible is. But we are landing in a space where you are discussing materials that actually contribute very little from an energy perspective. So I think it is much easier to make a case that there is some element of coincidence, because the only real parameter that the A classification is providing is really the heat of combustion. And we have seen that most of our tests direct us straight into the heat of combustion. So I could provide some element of analysis that would link me, that could link A, with some of the existing approaches. Now, if you allow me, this is I think something that is really important, and I think it has been emphasized that there was a pressing need, by European directives to try to make these matches of classification. And I do recognize that those pressures are obviously there, and there had to be something that needed to be done. And I think this is something that I find extremely difficult to digest in many ways, because we do recognize that the SBI and the European classification is not appropriate for this particular type of configuration, which is the external building envelope. And so we do recognize that. And the approaches that we're using in the UK, we recognize that they are not appropriate either. Nevertheless, the SBI has a wealth of information, and that wealth of information can be exploited. The part that I really don't understand is, instead of taking what is on the shelf and just going and saying, well, we just pick class 0 and we match it without absolutely no consideration to the physics and in a completely arbitrary way, why we didn't really do a proper analysis of the SBI, extracted from the SBI all the parameters that we could possibly extract them, construct a test locally that supplements it in a way such that we created that coincidence in a fundamental way, and that actually represents the potential need for safety for the system. So it's almost like the option is, oh, we're being pushed to do that, so we do the simplest thing, which is just take something off the shelf, and we don't think twice about what that means, instead of actually putting the effort to try, because as I say, the SBI has a wealth of information, and that information could potentially be useful in a classification. If it's treated just as a scenario test and you're just copying the classifications, you're going to enter a space of being of misusing the classifications. But if you take a step back and you treat it as a test, and then you analyze the information that you get and you supplement it appropriately, we could have come up with an equivalent system that would have not infringed the European directives, and at the same time deliver us a testing regime that was highly appropriate.
Yes, thank you. And is it right that none of the European tests give any information relevant to thermomechanical performance at the moment?
No, I mean, I think none of the tests that we have addresses the thermomechanical behavior at this point.
Yeah. And I think we'll come on to that in the context of 8414 as well in a moment. I just want to look at some of the evidence we heard in Module 6 relevant to this. And I want to look at the evidence we heard from Dr. Debbie Smith, the former Managing Director of BRE Global. If we could go to the transcript, this is day 234 of the transcript, and I want to look at page 115. And so the question begins at line 4 from Mr. Millett, and he says, do you agree that the SBI test was, in basic terms, introduced in order to replace the room corner test by providing a method by which the results of that test could be inferred without incurring the same cost in time and money? And she says, no. Now, just pausing there, do you agree with that?
Technically speaking, I do, in the sense that it was never intended to replace. Nevertheless, the objectives of both tests are fundamentally the same, and they're just simply at a different scale. And so I do agree that technically it was never intended to replace.
Yeah.
And but as I say, they have similar objectives, let's put it that way.
And I think she actually goes on to clarify. So then it says, no, you don't agree. No, I don't. The room corner test was the reference scenario which was used for the development of the single burning item test. It was never intended, as far as I'm aware, that the route to classification would be using the ISO 9705 test method. That's the room corner test. It was a reference scenario. Would you agree with that way of describing it?
Yes. I mean, I think the two of them have exactly the same sort of reference scenario. And it was always considered that ISO 9705 was too complicated, and uncertainties are big because of the size, the scale, to use it as a route to classification. So in a way, by reducing the scale, making it more confined, putting better measurements, you could actually have a classification that was a bit more robust.
Yes. Let's look at the next page, page 116. sorry, actually go back to page 115. I want to pick it up there at line 22, right at the bottom. So then another question. Did you ever yourself consider whether that test, that's the SBI test, was useful for assessing fire behaviour in circumstances far removed from the test scenario, for example, on the external face of a high-rise building? And then over the page, she says, yes, I did consider that, and it clearly is not suitable for that. And much of the work in Europe has focused very much on the identification of relevant reference scenarios, which then form the basis for the development of a European test standard. Now, so she's saying she considered that and it was not suitable for that. Do you agree with that statement?
I think I feel that there's a misuse of words. I think what she is referring to is the standard and the classification that it provides that is not suitable. But she is not really thinking carefully about the fact that as a test that is producing data, the data could be useful. So I think, I'm not disagreeing with what Dr. Smith says. I think it just requires a bit of clarification, because I really think that she's thinking as a standardized test, the product is the classification, and as such is highly inappropriate.
Yes. Whereas I think what you're saying is the position's more nuanced, because actually there is some data in that test that a competent professional could use, provided they know what they're doing, and then they understand the differences between the scenario in that test and the one they're investigating.
Exactly.
And then if we go to page 118 and look at lines 1 to 12, the question comes at the top of the page. During that process, harmonisation or later, did you ever say in very, very simple terms, almost lay terms, if I may, look, why have we got a test based on flashover being applied to the external build-up of a high-rise building? And she says, not in those terms, no, but I mean. And then the question, why is that? And then she said, it was well understood through the fire sector in the UK and in Europe that the whole premise of the classification systems were based on reference scenarios. And there's a European guidance document that exists that sort of explains all of that. Now, do you understand her to be saying there that it's the classifications that are the problem, not the test data obtained itself?
Exactly. So now she comes back and the terminology is used in a more precise manner. So she's talking about the classifications, and the European guidance document that she's talking about actually does discuss the scenario and what the room corner test and the SBI intend to represent. So I would agree with that statement.
Yes. I just want to pick up on another aspect of Dr. Smith's evidence. If we could go to her witness statement now at BRE 405624, and I want to look at page 8. And I want to read with you paragraph 24. So she says this: following a fire in a refurbished block of flats in Liverpool in 1991, it was accepted that a large-scale fire test method was needed to provide a better means for assessing and controlling the potential fire hazards associated with external cladding systems. That test would involve the complete system as installed as closely as possible to what would actually be installed onto a building. This was clear recognition that it was not possible to rely on small-scale fire test data on individual elements, materials or components in a cladding system as a means to try to predict and thereby control the fire performance. Reliance on small-scale fire tests had been tried and had been shown to be inadequate. Now, do you agree with what she says there, that it's not possible to rely on small-scale fire test data and individual element material data or components as a means to try and predict and thereby control fire performance?
Yeah, this is, again, I think there's a little bit of a confusion of words here, because I think I will fully agree that you cannot rely fully on small-scale test data, because the reliance implies that you have everything that you need to be able to predict performance. And clearly, as you're moving into a system behavior and you have multiple components that are assembled, then those components are going to come at a certain scale, and you have to start moving into that scale to try to understand the pieces that are missing from the small-scale test. So going back to the Queensland model, that is sort of the process that the Queensland Queensland model wanted to follow, which is get as much as you can from the small scale, then move to the next level, get whatever is next, and then finally, get that and then validate. So I think that I would not disagree at all with the concept that you cannot fully rely for this particular type of problem in small-scale tests. But the inference that therefore you have to go straight to a large-scale test is the part that I think is a bit problematic, in the sense that inference is not direct. You get to a large-scale test when you realize that you cannot get the information otherwise. And because we all recognize the problems, the uncertainties, the difficulties of the large-scale test, and that's the basic reasoning behind moving from the room corner test to the SBI. So in many ways, the large-scale test is the last resort where you can actually not get the information that you need. So I think the two terms in the same sentence are a bit complicated for me to understand. And but I do recognize the process that eventually can lead you into a large-scale test.
Yes. So I think what you're saying is one of the problems here is that it's treating it as if it's a binary problem.
Exactly.
Either you small-scale test or you large-scale test. And in fact, that's ignoring the complexity of the problem.
Yes, and it's the mindset that I was describing during my presentation, that if you don't understand anything, then you go and make the big burn. And that almost becomes the substitute, to understanding and to knowledge and to competency.
Yeah. Just one final passage of Dr. Smith's evidence. If we go back to day 234, I want to look at page 147. And I want to look at lines 5 to 15 here. And the question comes, but generally speaking, your point about the unreliability of the small-scale tests. She says, yes, I mean, the key thing with the small-scale tests, and in the case of Class 0 and the Part 6 and Part 7 tests, is that you're unable to install them with a representative fixing system. You can go as far as to install them with a different substrate behind them or with an air gap, but that's about as far as you can go. So you can't replicate some of the, important design variables that are potentially important when it comes to, large-scale systems. Now, again, if the implication of this evidence is that in contrast to small-scale tests, large-scale tests can replicate all of the representative details which will give you the answer to whether that facade can be used. Do you agree with that?
Unfortunately not, because I think, again, it goes back to the words. I mean, the generally small-scale tests are input tests where you run the test to harness information. That's mostly should be the objective of them. And a large-scale test can become a scenario test, in which case you're trying to replicate something. But you cannot mix the two. I think these things need to be broken down in a much more refined way, because I think what we are doing is mixing two different things that cannot be mixed. And the ultimate consequence of doing so, it once again reinforces the mindset that if you cannot replicate, if you cannot understand, if you cannot get the information, then you have to go and burn big. And I don't think that is an appropriate way of proceeding.
Thank you. Mr. Chairman, is that a good moment for the morning break?
Yes, it is. Thank you very much. Well, we'll have a break now, Professor Torero. We'll come back at 25 to 12, please. And again, please don't talk about your evidence when you're out of the room.
Thank you.
All right, thank you. Thank you, Ms. Grange. 25 to 12, please. Would you ask Professor Torero to come back in, please? Right, Professor, ready to carry on?
Ready.
Thank you very much. Yes, Ms. Grange?
Yes, thank you. Can I just go back to one passage in this morning's transcript, just to ask you to clarify one thing before we move on? When we were discussing the SBI test, there was a passage where you said, so in the case of the external flame spread, so in contrast to SBI, you're not going to have a small ignition source. You're going to have a post-flashover flame plume that's going to be impinging. Now, is this right, that you don't necessarily have to have a post-flashover fire plume to get an external fire going? And I think that's we just explored that at phase 1 of your evidence.
Oh, yes. I mean, of course, you don't need to, but eventually you will.
Yes.
So the fire in the room is going to continue, and it is very likely. I mean, obviously, depending on the ventilation conditions and the fuel available, the room might never flash over, like in the case of Grenfell. So you don't need to have that. But the reality is that if you're a designer and you are designing a safe system, you have to consider that your fire will progress to flashover, that you will have a plume, post-flashover plume venting, and that becomes your design scenario, basically.
Yes, thank you. That's very helpful. So I now want to turn to BS 8414 and BR 135. We've heard about the history of the development of these two regimes from Professor Bisbee, and you cover it in your report as well. And is it right that in your report you're principally considering the 8414 test and the BR 135 classification system in terms of what they can usefully tell you about the performance of external walls? Is that your focus?
Yes.
And then you explain in your report that the 8414 test was conceived as a scenario test, i.e. a test that's designed to assess something which is considered realistic. However, like Professor Bisbee, you highlight that despite being conceived as a scenario test, it was made expressly clear, certainly in the third edition of BR 135 in 2013, that it does not directly correspond to the end-use scenario. That's a key point you make, yes?
Yes, it can't.
And if we go to your report, again, JTOR 706 at page 102, I just want to look at what you say at paragraph 12.2.19 in the middle of the page. And you say, despite being clearly conceived as a scenario test, BR 135 states the classification applies only to the system as tested and detailed in the classification report. The classification report can only cover the details of the system as tested. It cannot state what is not covered. When specifying or checking a system, it's important to check that the classification documents cover the end-use application. And you go on and you say, thus, while the test was inherently designed as a scenario test, it is not assumed to directly correspond to the end-use scenario. This emphasises the need for competent interpretation of the results of the test and has implications for how applicable the test output actually is. So now, just aside from that warning, which only came in the third edition of BR 135, would it have been evident to any reasonably competent fire engineering professional that this test would not correspond to an end-use scenario?
It should have.
Yes. And what you do is you analyse the development of BR 135 in your report, and you explain that the very first edition of BR 135 was devised as a scoping study. And if we look at what you say at page 103, over the page at 12.2.28. So you say, upon inspection of this report, that's the 1988 BR 135, it becomes clear that this experimental series was originally devised as a scoping study and was not in any way intended to be the development of a test of these systems' performance. Now, can you just explain for us exactly what you mean by the fact that you say it was devised as a scoping study?
Yes, I think that for me, the difference between a scoping study and a study that is designed to develop something that is of general application is the breadth of the different systems, conditions, and characteristics that you are going to use to support the development of the test. So if the conditions are very, very limited, and then what happens is that the information that you are collecting might pertain only to a very narrow set of systems. Now, if you want that to become a standardized test and you want that to be used broadly, then you would have had to do a much, much, much broader set of scenarios, characteristics, and so forth until you narrow down exactly what is the condition that gives you the most information or the information that you actually need.
Yes, and you explained that first edition looked at certain specific systems, including one system which was an aluminium-faced cladding system incorporating expanded polystyrene, with the extent of the cavity being limited by fire barriers. So a very particular type of system.
Exactly.
Yes. And then at 12.2.29, just going back to that page, you say this, you say, furthermore, the focus is on risk of flame spread, surface and cavities, but it bears no relationship to the objective of supporting a fire safety strategy. So when the objectives indicate that the purpose is to identify the design principles, they relate to an undefined concept of risk of flame spread. So I think you're critical of the fact that there's no defined objectives which tell you what concept you're seeking to classify in this standard. Is that right?
Exactly.
And then you say in the following paragraph at the bottom of that page, as a result, and from the outset, BR 135 and the research supporting it leaves it to the interpretation of the competent professional to determine what the objectives of the test are and how to embed the concept of risk of flame spread, surface and cavities in the assessment and definition of the fire safety strategy. So I think what you're saying is because it only ever is addressing this generic risk, ill-defined risk of flame spread, the competent professional has got to take that, but then work out what type of fire safety strategy they're designing and whether that risk of flame spread is compatible with that fire safety strategy. Is that right?
Yes, and beyond that, the competent professional has to be able to extract the information and determine whether that information enables them to define appropriately the adequacy of the fire safety strategy, but also they should be able to establish when that information is either insufficient or inappropriate.
Yes.
So, for example, if you were to alter the system significantly, or you have a system, for example, that has a balcony, and that balcony has certain characteristics that might completely invalidate the test, the competent professional should be able to make that assessment.
Yes. And one of the points you make is about the extent of focus in BR 135, all through all three editions, on cavity barriers. And I just want to look at some of what you say about that. If we go to page 105 now, and we pick it up at paragraph 12.2.37, you say this, you say the second recommendation indicates that flame spread will be inhibited if access to further fuel is prevented by an effective barrier. This is a specific way to attain the heating length equals 0 in a manner that is not intrinsic to the combustibility of the materials involved, but by means of a mechanical barrier. And you go on, thus both recommendations are specific to the systems studied and are not influenced by assessments of combustibility, but by assessments of thermomechanical behaviour. And you go on, you say the second recommendation is important in the context of subsequent historical perception of the risk posed by rain screen facade systems. As stated above, the external panels considered at the time were uniformly non-combustible, likely representative of the products on the market at the time, judging by the scope of the document. Therefore, spread of flame over the external surface was not a possibility, would not have been observed, and thus was never addressed in this document. And then you go on at 12.2.40. The principal hazard identified was the elongation of flames contained within a cavity, and seemingly as a result of which, ever since, the publication of this document has historically been perceived as the most critical threat in regard to these systems. Thus, the provision of cavity barriers has remained the primary focus of industry and regulation, and was typically the sole consideration when assessing the risk posed by rain stream facades containing no combustible materials. So, is it your opinion that we can trace the focus of industry on cavity barriers, and cavity barriers effectively solving your problem of external fire spread, at least in part to this first edition of BR 135, which had this acute focus on flame elongation within a cavity?
Yes, and I mean, at least that's sort of the impression that I get by reading the document, and again, that is caveated by the fact that these were very specific systems in which the cavities have certain dimensions that seem to promote the elongation of flames, which is not always the case with cavities. So yeah, I mean, I think there seems to be a coincidence between the two of them, but as I say, it's an impression that I get by reading the documentation.
Yes. Do you think Professor Bisbee's right that cavity barriers are something which has received particular focus in this jurisdiction, but which hasn't received the same attention internationally in many other jurisdictions? For the transcript, the reference to that is at day 290, page 162, lines 4 to 14.
Yep. The cavity barriers are something that will appear in most jurisdictions, and obviously there is a recognition that under certain conditions, a cavity in itself represents a chimney, and under those conditions, it has the potential to accelerate fire spread. And but the enormous emphasis that is given in the UK is not parallel elsewhere, where it is just simply seen as yet another element that needs to be complied with, as many others. And I think here we do get a very significant emphasis on cavity barriers without really paying too much attention to exactly what they're doing and whether it is as beneficial as they are perceived to be.
Yes. So would you say that the focus on cavity barriers in this jurisdiction has potentially been disproportionate to the benefits that they can potentially achieve?
Yes, the focus has to be disproportionate to the effort that has been put in understanding how beneficial they can be. It's been an assumption that if we put cavity barriers according to certain characteristics, those cavity barriers will be immensely beneficial. And but that requires an element of effort to understand if effectively that is the case, and I think that effort has never really been there.
Do you consider that their role in the approved document and their promotion in the UK market has given a false sense of security that provided cavity barriers are present, the cladding system will be safe and will resist the spread of fire?
I mean, this is the case with multiple, fire safety systems. The cavity barriers is one of them. Sprinkler systems are another. That in many ways there is this oversimplistic extrapolation that if I put this, then I am safe, and that false sense of security is, I find, something very problematic.
And you make the point in your report that later editions of BR 135 continue to focus almost exclusively on the threat of fire propagation through cavities, with very little reference to the risks posed by flame spread through the external panels themselves. Is that correct?
Yes.
And if we can look at what you say on page 106 now, the next page in this section, paragraph 12.2.44, you say this. You say, while this perception of the risk posed by modern facade systems may have changed in light of the external fire behaviour at Grenfell Tower, there is still a significant industry focus on the type, location and orientation of cavity barriers. This is despite the fact that external fires of the nature of that of Grenfell Tower clearly spread over the external facade. A clear technical assessment of the role of cavity barriers in reducing or preventing external fire spread is currently not available. This again is demonstrative of the endemic perception in industry of where the risk lies when addressing rain screen facade systems. Now, I want to pick up on that penultimate sentence where you say, a clear technical assessment of the role of cavity barriers in reducing or preventing external fire spread is currently not available. What do you mean by that? So
if you look at the entire technical literature in fire safety, you will find almost a complete absence of any studies that really address cavity barriers in a systematic way. I think I'm probably one of the few people that has actually studied cavities globally. There's no emphasis at all in trying to really understand how they work.
And is that a complex piece of work that really needs to be done in order to understand how they work better?
Yes, of course, because it is a complicated problem in the sense that the size of the cavity is critical in the way in which the cavity barrier either promotes or in many cases hamper the progression of a fire. And I think in many ways it bears a significant correlation with the actual with other functionalities of a building envelope, because the reason why we have cavities is not because of fire. The reason why we have cavities is because of other functionalities. And we introduce all these components that have a detrimental effect on these other functionalities of the building envelope without really having a true understanding of what benefit we're gaining by introducing these elements. And obviously from a constructability perspective, there's so many other areas that get affected by the fact that we keep introducing these cavity barriers. So we really need to understand it, and it's an area that has received almost no attention.
Okay, thank you. Now, let's just look at what the later versions of BR 135 do say about external fire spread through the panels themselves. If we look at the third edition from 2013, this is at BRE 16665. There we have the third edition authored by Sarah Colwell and Tony Bacon. If we could go to page 22 in the right-hand column, so under the word combustible, so in the second half of the page, there's a bold, so it says this: combustible panels are typically based on vinyl or glass reinforced plastic, although various new products are being developed in this area, some of which also contain insulation materials. These products generally have good surface spread of flame characteristics to prevent rapid fire spread across the surface of the system, but once the panels become involved in the fire, they have the potential to generate falling debris, add to the overall fire load, and provide a route for fire to propagate up the outside of the building. Now, you make the point in your report that there's nothing more than that in this document about how to assess the risks that are being described there. Is that fair?
Yeah, that's correct.
Now, there are performance criteria in the appendix. Let's just look at the appendix of this third edition on page 29. This is Appendix B. It's the performance criteria and classification for the 8414 Part 2 test on steel frame systems. And if we turn to page 31, we can see there's a heading, Performance Criteria and Classification Method, there on the left-hand side. And then if we go to the top of the next column, top of the right-hand column, in the second line, it says the performance of the system under investigation is evaluated against the following three criteria: external fire spread, internal fire spread, and mechanical performance. And then over the page, if we go to page 32, we can see that there are some criteria then set for performance. But we can see that, well, actually, if we go back a page, we see the criteria for external fire spread at the bottom of the page. It's right, isn't it, that this is expressed purely in terms of failure. Is that right? Failure due to external fire spread is deemed to have occurred if the temperature rise, and then it goes on to explain what the specific requirements are for failure.
Yes, absolutely. I mean, I think that the title of Section B2 is misleading because it is not a performance criteria and it is not a classification. All it is a statement of failure, and so it doesn't provide you any further information other than a certain set of systems that will actually fail the criteria.
Mm. Yes. And do you understand the rationale behind these failure criteria? We've asked a number of witnesses at Module 6 to explain it. Do you understand what the rationale is for those failure criteria?
There is no rationale behind them other than just simply typical values that you will use to characterize the presence of a flame. So if you look at the data that is available on flames, what you will find is that there is an area of the flame that is called the continuous flame, which is an area that is always burning. And normally the temperatures in that area will be about 800, 900 degrees. And then you get what is called the intermittent flame, which is a period of pulsation. And in the middle of that, you will be around 600, 700. And then by the time you get out of the area that is actually burning and you just get hot gases, you're down to 400. And I think it's just simply they've used a characteristic value that is commonly recognized as being somewhere in the range of things that burn.
Right, but you can't.
It's arbitrary.
I see. It's arbitrary.
Yes.
Yeah. And you also make the point in your report for the transcript, that's at page 97, paragraph 12.2.11, that having this simple temperature system is not capable of distinguishing between a small flame close by or the smoke plume from a larger flame at a distance.
Exactly, because, as I described, you have these different sectors of the flame, so as the flame increases in size, everything increases in size. So if I have a big flame, I will have to be very far away to be at 600. Well, if I have a small flame, I will have to be very close to be at 600. So it doesn't allow you to distinguish what is really happening.
Yes. And it doesn't enable you to tell whether it's the smoke that's heated that or the flame itself.
Exactly. So you could have, for example, a membrane where you have a little flame that is creeping up. And if it gets to the thermocouple, it will get to 600 degrees. And, as opposed to if you have a very big fire underneath and then the smoke could be at 600.
And is this one of the reasons why you say that the failure criteria simply don't relate to the objectives of the test?
Yes, because at the end, we are talking about fire spread. So the objective of the test should be to characterize the capability of the system to sustain or adequately resist fire spread. And it's not necessarily linked purely to the characteristics of potentially the smoke, for example. So there's not a one-to-one correlation between the two.
Yes. Do we get any guidance within this document as to what the significance of a pass is to BR 135?
My understanding is that there's no such a thing as a pass. It is just a failure criteria. And the pass is defined by the competent professional in the use they make of that information. They take the information, they apply it, to their building, and they decide if it actually meets the requirements of the fire safety strategy, so that their holistic fire safety strategy meets the regulatory requirements of the 5 functionality pillars.
Yes. So you just failed the test, but I think what you're saying is that doesn't tell you anything about whether then you're satisfying a particular fire safety strategy and meeting a functional requirement.
Yes, absolutely.
Do you agree with Professor Bisbee? His characterization of it was that the only thing this test really tells you is what would be a really bad idea to use. Do you agree with that? Yes,
as I described it in a different way. I said basically your failure criteria cuts the tail, of the really, really bad systems.
Yes. And for the transcript, that was day 290, page 143, lines 7 to 8. So again, does that leave it to the designer to decide what the significance is of the fact that you've not failed this test? But I think what you're saying is it certainly doesn't tell you that it's okay just to crack on and put it on an external wall.
It's clearly not a pass. So all that it tells you, if it doesn't fail, is that you have to take that information and then make good sense of that information to guarantee that it fulfills the needs of your fire safety strategy.
Yes. And if we look at page 109 of your report, at JTOR 706, page 109, and I pick it up at 12.2.62. So you say, as has already been discussed, the process of interpreting the performance requirements defined by ambiguous statements in the building regulations must be inherently linked to the fire safety strategy of a building, whereas a fire safety strategy with a controlled evacuation can allow for a conservatively defined degree of external flame fire spread. A fire strategy with a stay-put policy in place cannot allow any. And then you go on, if I pick it up at 12264, you say it logically follows that a facade system can meet the BR135 performance criteria and yet still be entirely incompatible with the fire safety strategy of a high-rise residential building with a stay-put policy in place. And then you go on in the next paragraph to explain that the information provided by the thermocouple arrays do not establish, including the ignition temperatures of the products and whether they're sufficiently high, the length scales of any flames, and whether or not the flame will tend to extinction. And with regard to a controlled evacuation strategy, it also doesn't tell you the actual rate of external or internal flame spread, the length scales of the flames established, or certain material properties.
Yes, that's correct.
Now, would it be possible to run these large-scale tests, but in a way which collected a larger pool of useful data?
Absolutely. I mean, I think I can even think of the most sort of simplistic approach. You already take videos of these tests, and if you could actually do a very careful analysis of the video, will give you some estimate of the rates of flame spread, for example.
Yes. If we go on to page 110, the next page, at 12.2.72, you say right at the bottom of the page, the BR135 BS8414 approach is presented by approved document B2019 as an alternative to following the more simplistic alternative that restricts material combustibility. In spite of this, the BR135 assessment does not translate data from the test to a classification of combustibility that could be used to assess the adequacy of a system. So just to be clear, would it be possible to translate data from a good large-scale fire test into a classification of combustibility that could be used to assess the adequacy of a system?
Yes. I think, again, it all goes back to the less you measure, the less you observe, the more difficult it becomes and the more competent the person has to be. But clearly, there is information in the test that can be used. And as it stands, with the simplistic nature of what we measure, probably you will have to use that information to infer something extremely conservative. But yes, of course, you can always extract information from a test.
Yeah. Just going back to the third edition of BR135 again, so BRE 30s 1, 36s 5 at page 32. I want to ask you now about mechanical performance. We can see there what it says under the heading on the left-hand column is no failure criteria have been set for mechanical performance. However, ongoing system combustion following extinguishing of the ignition source shall be included in the test and classification reports, together with details of any system collapse, spalling, delamination, flaming debris or pool fires. The nature of the mechanical performance should be considered as part of the overall risk assessment when specifying the system. Now, is that another example of the requirement for a designer to assess this information and then apply it to their particular situation?
Yes, and I think in this particular space, it is described in a manner that completely underestimates the complexity of that problem, because you have so many forms of mechanical behavior that need to be considered, from the failure of the encapsulation, for example, to components falling off, to deformations that will allow smoke to migrate to the upper floors, for example. There's so many aspects of mechanical behavior that are all summarized in those 8 lines that I think it misrepresents the importance of that particular problem.
Yes. So I think you're saying that's simply not a satisfactory way of dealing with mechanical performance.
Not at all.
And is it your evidence that it would be possible to provide some form of classification system or criteria for mechanical performance if one wanted to do so?
Yes, I think if you really understand what you're aiming at, you should be able to create a criteria. Just to give you a very, very simple example, we introduced these fire stops between the facade system and the concrete slab, and we filled them in Okay, so I could introduce, for example, a criteria of mechanical behavior that does not allow for a deformation that is bigger than a certain gap, with that stop can fill in, by its own natural expansion. So you can actually look at the systems and say, what I want is this gap to never open. And because I don't want that gap to ever open, then I have to restrain expansion to some level so that all the components fulfill its function. So there are ways by which you can establish some performance criteria, and you can make them more complicated or simpler. I mean, you can simply say that you don't want to allow any smoke to be above the barrier, and put a measurement of smoke concentration right above. And the moment that smoke gets beyond a certain threshold, you can say, well, then the smoke has creeped in, and therefore the mechanical deformations are allowing smoke to fill the compartment above. So there are many ways in which you can do it. It is a complicated problem and needs to be carefully assessed, but it can be done.
Yes. Then if we can look back at your report, JTOR 706, page 111, I want to see what you say at 12.2.76. You say this here. In respect of rain screen systems, deformation of such systems as described in the main body of the BR 135 report, second edition, can lead to the creation of gaps that allow flame penetration behind and through the facade system and directly into the unit above. The absence of another opening above the fire compartment in the BS 8414 test makes even a visual assessment of the propensity for such a compartmentation failure to occur almost impossible. Thus, failure by deformation of the system is not an aspect which is assessed by BS 8414 BR 135. So is this right? I think what you're saying there is that for rain screen systems, given specific ways that they can deform and gaps can be created, it might be a good idea to have some large-scale fire tests which actually have additional penetrations above the original fire compartment, so that you could at least observe how the fire reacts with those additional penetrations. Is that right?
Yes, that's correct. And even beyond that, SP 105 actually does have that. So the Swedish test does include a penetration in the floor above, so that you can actually assess the conditions behind. Now, they don't look at mechanical behavior either, but nevertheless, they do make an assessment of what happens in the compartment above.
Yes. And having windows and a compartment above, is that always going to be necessary? Would it vary depending on the system that you were assessing?
Well, I mean, I think it depends mostly on your fire safety strategy. So if you are relying on a staple strategy and you're putting no other provisions to compensate for the fact that your compartmentation might fail, then you do need to make that assessment, because you're fully relying on the integrity of the compartmentation and the fact that there will be no smoke or flames penetrating into the compartment above.
Yeah. But is there a role for, I mean, I appreciate everything you've said about what the role of large-scale testing is. Is there a role for a better large-scale fire test, which has, for example, as a standard assumption, an additional penetration in it? Yeah,
I'm actually convinced that there, in this particular case, because you're talking about complex systems that are at a scale that is the scale of the compartment, that there is a role for a large-scale test. Now, I think the objection that I have to the current large-scale tests and the approach that is followed towards large-scale tests is that they are not based on need. So it's not a demonstrable need that has come from a very systematic and rigorous assessment of what is the information that I need to collect. They're just a substitute, to the fact that we don't understand how the systems behave. So at no point I am saying that there is no need for large-scale tests. I'm actually quite convinced that for a system like that, you will need some form of large-scale tests. It just simply has to be designed, and instrumented, and analyzed in an appropriate way.
Yes. So I think what you're saying is you could have better large-scale tests, but standardised ones as part of any comprehensive system?
Yeah, I mean, I think the last word that you used when you said standardized, I mean, I think that to me that's where we run a little bit into trouble, because for me, standardization is the product of understanding. So once you've understood something fully, you can come up with a standard, simpler version or a standard version that enables you to obtain the information in a systematic way. And I think the problem is that when you're talking about this type of products, the way in which they evolve, and the fact that they're being used with a building, and the buildings are going to be generally always different, then there is an element of bespokeness that is very difficult to break. So the concept of a standardized test might be much more valuable at the smaller scales, while the large-scale test will always be an ultimate need, when you have a bespoke system that needs to be assessed, because you're now talking about the full system. So I think we have to be a bit careful in the way in which we look at this, because standardizing large-scale tests can only be done if you truly understand the problem that you're working with. And if the problem is going to vary for every building, then that is actually not possible. So we have to be quite careful with the use of standardized. But
yes, I think I understand. So I think what you're saying is that in any ideal system, you could have large-scale testing to validate results and to provide data and information, but not necessarily the same test for all systems.
Exactly.
And you might need to have some flexibility in the way you arrange your test, depending on what it is you're seeking to understand.
Exactly.
Yeah. Now, linked to that point, if we go to page 191 of your report, paragraph A223. So this is in the section of your report, it's in the appendix, or one of the appendices, where you're analysing whether there's good literature out there on the way in which external fire performance should be assessed. And you explain at paragraph A223, you say an attempt to analyse the shortcomings of the different test approaches used in the UK, mainly BS 8414, was conducted by Schultz et al. And the footnote takes us to a number of individuals, we can see there, contributing to a paper called A Critical Appraisal of the UK's Regulatory Regime for Combustible Facades that was published in 2021. And you go on, you say, this study aims to establish a critical assessment of the current testing regimes of relevance to facade systems. The authors correctly conclude that the process by which combustible facades are permitted on tall buildings in England does not ensure fire safety, and insist that a new and more robust approach is required. And then you go on, you say the scope of the paper is limited to the BS 8414 testing protocol, the performance criteria in Annex A of BR 135, and the MHCLG sponsored tests. Those are the ones carried out after Grenfell, I think.
Yes.
The analysis discusses details such as the ambiguities within the BS 8414 protocol, reproducibility, strong sensitivity of the outcomes to many variables, and the lack of alignment of the criteria in BR 135 to any specific objectives of the fire safety strategy. It is clear that reproducing realistic facade systems is very difficult in a test, so some degree of extrapolation will always be necessary. The authors use the MHCLG test to illustrate this problem and how small differences can significantly alter the results. Finally, a series of recommendations are provided that correctly stipulate the need for more reproducibility, better measurements, and more clear reporting and transparency in regards to the objectives and motivations for the test. And you go on and you provide an opinion in the next paragraph, A2.25. You say, while it is impossible to disagree with any of these statements, this study fails to establish the fundamental weaknesses of the test or to establish the key variables that will affect the quantification of external fire spread in a manner that supports the fire safety strategy. Furthermore, the study provides no critical analysis of what is required for a correct extrapolation. A test delivers data, and that data needs to be interpreted. Data that has more imperfections does not mean that the data is useless. It only means that a more complex interpretation is necessary. Without this critical analysis, this study does not enable any advancement towards a better compliance regime. And just to orientate ourselves, if we bring up that study, it's at INQ 3014943. That's the study in question there. Now, what exactly do you mean when you say at the beginning of the paragraph I just read that this study fails to establish the fundamental weaknesses of the test? Is that it fails to recognise the fundamental weaknesses of 8414?
Exactly. So at the core is the things that we have been discussing that fundamentally make this test limited. And from issues like not being able to assess mechanical behavior to other issues of very poor instrumentation. There's so many of these fundamental weaknesses that are not touched upon in detail in that study.
And when you say that it fails to establish the key variables that will affect the quantification of external fire spread, does that go back to your presentation where you identified
Exactly.
the key variables? But do you think it would be possible to make the 8414 test much better in terms of the data it produces so that it was more useful to fire safety professionals if it was chosen as a test to be used?
Yes.
Yeah.
But you have to always consider the fact that it is a test. And as such, it's not there to fully reproduce reality, but to provide information for a competent professional. But by improving the test, you reduce the onus on the competent professional, and you create a much more effective and robust set of data that can be used in support of your fire safety strategy.
Yes. But I think what you're saying is that you could improve the test, but it still wouldn't matter how good the test is because there would always be a need for some extrapolation of the test results and judgment by the competent professional.
Exactly, and I think, for example, the issue of very small changes can make an enormous difference. I think this is very common with problems of encapsulation, and we saw it in Professor Bisbee's tests, that very, very small changes can have a very drastic difference in the outcome. And that is something that is not a flaw of the test. It is actually a weakness of the strategy that we're following to protect the combustible material. And I think by directing the attack on the test because of those changes, what we're doing is failing to recognize the intrinsic weaknesses of the strategies that we're using to protect combustible materials.
Yes, thank you. Now that takes us nicely to desktop assessments and some questions about those. And I'm going to ask you some questions about those and about BS 9414 and the guidance that now gives to those carrying out such assessments. But before we do, just stepping back and thinking about this generally, are desktop assessments or extrapolations from test data a scientifically valid basis upon which to make assessments about external wall performance?
Yes, a desktop study is another expression that describes an engineering assessment. And as a competent engineer, I will most likely always have to supplement the information that I have with calculations, with analysis, with other additional knowledge. And once we document that into our report, that is what becomes a desktop.
Yes. Now let's look at the section of your report in which you deal with this. If we could go back to your report, JTOR 706 at page 114. And if we look at 12.2.93, this is where you've got the section on desktop studies. You say, as described earlier, the use of testing to establish the performance of systems to be used in buildings potentially requires multiple levels of analysis. Parameters of verified magnitudes can be introduced into models and potentially combined with different approaches to performance testing so as to determine if the system, in the context of its application, fulfills the requirements of the fire safety strategy. This information has to be analysed by a competent professional and delivered through a desktop study. Thus, a desktop study is an inherent component to the practice of fire engineering. Now, just pausing there, have you yourself ever carried out desktop assessments?
Yes, many times.
Yeah. And then carrying on with 12.2.93, you say this: any parameters that are deemed critical to attaining the required outcomes of the fire safety strategy should be independently verified for conformity. The parameters are combined through a desktop study to define either the performance of a subsystem or that of a building envelope. The fire performance of the subsystem or the building envelope also needs to be verified for conformity. The parameters describing the fire performance of the building envelope will serve as an input to the performance assessments in the fire safety strategy. Thus, the fire performance of the building envelope is not in itself compliant, but it can be deemed by the competent professional to conform with the fire performance expected of it by the fire safety strategy. The vehicle by which these assessments are presented and recorded are the desktop studies. The assessment of a fire safety strategy might incorporate several desktop studies. Now, in terms of that last comment, that the assessment of a fire safety strategy might incorporate several desktop studies, can you just give us some examples of what you mean by that?
Yes. So, for example, if I'm looking into the performance of a facade system that actually has combustible elements in it, and there will be an analysis that will be primarily led by a fire safety engineer to look into how those combustible materials are going to enable the spread of a fire. Now, that can be complemented, for example, by an analysis that is done jointly, but this time led by a facade engineer, where a fire engineering is providing the input temperatures to look at the formations. And those deformations will produce gaps, and the quantification of those gaps then is going to be fed into the fire safety engineer report, and showing that those gaps do not create conditions that challenge the fire safety strategy. So just with that simple example, I have talked about 3 desktop studies that could be led by 3 different individuals. And nevertheless, they all form part at the end of the fire safety engineer's fire safety strategy demonstration of performance.
Yes. Now, just some very general questions, and these might be hard to answer, but I want to get some sense of this from you. How difficult are these assessments to do properly and competently?
They are difficult. They do require a very competent professional, and it also requires a professional that has some level of understanding and is interacting in an effective manner with professionals in other disciplines. As I described, for example, in the case of a facade, you're going to have an architect, you're going to have a facade engineer, and you're going to have a fire engineer. And to be able to do a proper assessment of mechanical behavior, you probably need the input of all 3, at least. And so they are difficult, to be done. I mean, I think there is only one caveat that I have to put to that, is that you can make them simple. And you can make them simple by being very conservative. It still requires you to be very competent, but nevertheless, you can simplify the analysis to a point where you don't need a 1-year study to resolve that. You could actually do it within the timescales of a typical engineering analysis. And it will still require a competent individual, and many times simplifying requires more competency than doing things brute force. But I think the concept of conservatism and factors of safety is a mechanism that we have, to make more mainstream our calculations. And but that requires a level of conservatism that many times might be unacceptable to the construction industry.
Yes. And that was my next question, which is how cautious should those carrying out such assessments be? And it sounds like you're saying it depends. And if you're doing a simplistic assessment, you might need to have lots of factors of safety built in to ensure that you're the right side of any line.
Exactly. I mean, your analysis has to be robust. It has to be extremely explicit. And if you're going to make those assumptions to make your analysis simple, doesn't mean that the analysis is simplistic. Is that your calculations are simple, and therefore all the assumptions have to be listed, have to be very carefully articulated, and they have to be made available so that they can be verified for conformity.
Yes. And we've seen, I think you've already made the point, that tiny differences, we saw it with the Edinburgh experiments, for example, just perforations in a tiny foil facer or difference in method of fixings can make a huge difference in fire performance.
Absolutely, and this is where you become conservative. No? So if you have a protection system or an encapsulation system that you know is fragile, then you might simplify your problem by just assuming it doesn't exist.
Yeah.
And the moment it doesn't exist, you have immediately the ignition, and then you assess your system as a function of an unprotected system.
Yes. Was it an integral part of the Queensland system to teach people how to do proper extrapolations?
Yes, that was at the core of the CPD. You know, it's basically walking the professionals that were in the course through the process of building all the blocks until you finally deliver the performance of the system according to your fire safety strategy.
Yes. We've heard from Professor Bisbee about some historic desktop studies that he was asked to specifically look at. Are you aware of his report and his evidence on that?
Yes.
And have you considered his analysis of the 6 specific desktop assessments which he was asked to review?
Yes.
And do you agree with his criticisms of these desktop assessments?
Absolutely.
What does that tell you about the state of competence of those operating within the industry prior to the Grenfell Tower fire in terms of their ability to carry out such desktop assessments?
Well, I think that if you take those cases as examples of the practice and you assume that they represent in a faithful manner the practice, I think that those studies show that the people who were conducting them did not appreciate, one, the complexity of the problem, and two, the potential magnitude of the consequences of the mistakes. And the way in which they were done, the very significant lack of justification provided for many of the assessments shows, very clearly that the necessary attention to detail was not placed in those studies.
Were you surprised by what you saw in those assessments?
No.
No. Because why were you not surprised?
Well, I've done many third-party reviews, and I've done assessments of other people's desktop studies many times, and observing more or less the same approach to practice.
And how would you describe that practice?
Very poor.
Now, I want to turn to BS 9414 briefly now, which is a new standard which was published after the Grenfell fire in 2019, which you deal with in this section of your report. If we can go to it, it's at BSI 401934. So here we have it. It's called Fire Performance of External Cladding Systems, the application of results from BS 8414 Part 1 and BS 84 Part 2 tests. And if we go to page 9 of it and look at paragraph 1, under scope, it says there at the top, this British standard specifies procedures and rules used to evaluate variations and changes to products and systems which have been tested in accordance with BS 8414 Parts 1 or Part 2, and where appropriate defines options and limits for preparing reports based on the direct and extended application criteria provided. So is it fair to say that what this is some guidance that's intended to be followed and to help people carry out desktop assessments by extrapolating from 8414 data?
Well, that's what the paragraph says, but that's not what the document is.
How would you describe the document?
An absolute oversimplification of a complex problem that is full of mistakes from beginning to end.
Now, just sticking with the document a moment, if we go to page 7 and look at the introduction, it says at the top, there are a number of practical limitations on the size and design of construction elements that can be evaluated by a standard method of test. For example, if these elements are larger or of a modified design or type, it's necessary to be able to confirm that the integrity of the test result would be maintained if such changes to the system were implemented. This can be achieved through the use of standardized rules. Now, do you agree with what's said there?
No, as I explained to you before, what the objective of doing the assessment of a facade system is to establish if it actually meets what we need from that facade system for the purposes of the fire safety strategy. It is the fire safety strategy that is compliant. Now, the moment that this information is going to be applied to a specific building with a specific fire safety strategy, then the use of the word standardized becomes very limited. There's very few things that you can actually standardize when what you're aiming at is a bespoke assessment.
Yes. And if we go to the third paragraph here, it says this British standard is concerned with evaluating the scope of the results obtained from the 8414 tests, defining the parameters which can or cannot be varied and to what extent. It provides direct application rules for a system which has been subjected to a single BS 8414 Part 1 or Part 2 test and an interpolation for systems which have been subjected to multiple tests. And then if we go to Table 1 on page 14, we can just look at some examples here of the type of guidance that's given. So, and you pick this one out in your report. So you've got something that's tested on a masonry substrate as the tested substrate. And the variation is proposed that you're going from masonry to a board frame, steel frame system, and that's not permissible. We can see that under option for change. Then underneath, you're going from the tested substrate is a face steel frame system, and the variation proposed is from a board-faced steel frame system test to a masonry test. And that's said to be permissible, provided you've got some additional evidence of temperature in the insulation layer, fire resistance of substrate, thickness of the brick, block or concrete. Now, you single this out as just one. I mean, this is actually the first piece of guidance that's given, specific guidance in the report. You single this out in your report as a piece of guidance that you simply don't agree with. Can you just explain why?
Yes, I mean, if you think of Professor Bisbee's analysis, his tests, one of the very significant conclusions of his tests is that the insulating capabilities of whether it is the mineral wool or cellular plastic insulation have an extraordinary impact on the capacity of the aluminum composite panel to enter this runaway phase. In the absence of those insulating properties, this doesn't happen. The moment that you have the insulating properties, you get to this position. Now, the moment that we say, for example, that if you're going from masonry, to steel frame systems, and you say it's not permissible, that already in itself implies an assumption of what all those thermal properties are, with absolutely no mention of what those thermal properties are. You might assume that that under standard conditions, masonry is a much higher conductor than what a steel frame system is. But the reality is that I can come up with a product where that gets reversed, in which case I land on the other case. So effectively, what you're doing is omitting in this table the entire complexity of the problem. You're making lists and lists of assumptions. You're omitting physical processes. You're making all these jumps from one place to another one and landing into a decision. Not only that, on top of that, you are requiring additional evidence that obviously needs to be analyzed by a competent professional. So on top of that, you're putting disqualifications. So on the one hand, you're discounting the need for a competent professional, and you're delivering rules, because that's what it says at the beginning. And on the other hand, you're demanding that a competent professional does additional analysis. So in a way, I mean, just those two lines show clearly the inherent contradiction, the sort of lack of care to the assumptions that are embedded in those decisions, and complete disregard for many physical processes that can affect the performance of the system. An SFS system, for example, can deform much, much more significantly than a masonry system. And we have taken absolutely no regard of that. Workmanship. The implementation of an SFS system requires a very high level of workmanship, while masonry doesn't require that. And we have eliminated all these things and then land, with a conclusion that clearly does not necessarily cover anything beyond maybe what it is conventional and trivial to the naked eye.
Yes. In your report, you say that what this piece of guidance does is substitute a desktop study which should be conducted by a competent professional with simple tables. And you're very critical of this piece of guidance. Is that fair?
Yes. I mean, I think that you will find that there is a recurrent theme in all my reports that I'm extremely critical of any document that substitutes competency. And that's what this document does.
Yeah. Because what you're saying is these systems, these processes, they're far, far too complicated to be able to be simply understood or interpreted by reference to simple tick box tables, essentially.
Exactly.
Yeah. And the point you also make in your report is that because the 8414 test doesn't provide important, relevant information for assessing relevant fire performance, you're building error upon error. That's your view, is that right?
Exactly. So you're starting from a difficult place and you're just making it worse.
So does this 9414 document address any of the gaps that you've identified in the BS 8414 testing and classification regime?
Not in my opinion.
And is it right that your view is that it compounds and amplifies the gaps and weaknesses in BS 8414?
Exactly, because it is presented as a substitute to competency.
Yeah. If we could go to page 118 of your report, JTOR 706, page 118, we just get your summary paragraph on this. So you've said in more detail in your report why you've got concerns, and then at the paragraph at the top of that page, you say, in summary, BS 9414 is a document that follows a long tradition of attempting to ignore the need for professional competency by substituting the need for professional assessment by means of oversimplistic, non-comprehensive and flawed prescriptive rules. When tables 1 to 6 of BS 9414 establish whether a proposed variation is permissible or not, this assessment is many times incorrect. Furthermore, in most cases, the tables will also indicate the need for additional and competent professional assessment. Therefore, this new standard is not only flawed in its technical content, but it attempts to hide the need for the professional competency that the standard itself invokes. Now, is there anything equivalent to the BS 9414 guidance internationally? Has any other state gone down the route of providing this kind of guidance for desktop assessments?
Well, the NFPA document, the NFPA developed this software, but they're quite explicit in what they're doing. So they're not developing a table. What they're doing is a collected expert opinion. And on the basis of that expert opinion, they created a software that allows you to make a preliminary assessment of a facade system. Now, I mean, I'm completely against doing that too. Nevertheless, as opposed to BS 9414, first of all, they never qualified it as a standard or something that people should be following. It is just a software that they offer the community. And second, the expert opinion is so conservative in nature that unless you have a brick wall, it will reject everything, basically. So in a way, it's quite cautious of how far they go, and it's because of the nature of the fact that it's just a compilation of expert opinion. So that's the only, I would say, similar system that I know that has been proposed in the past.
Yes, and looking at this guidance and taking it as a whole in terms of all the guidance it's giving, would you describe it as a cautious approach to the assessment of external wall behaviour?
No.
Okay. Now, just to pick up on a few more topics dealt with in your report. In your report, you discuss some historic large-scale reconstructions that were carried out for forensic fire analysis. And as part of that, you've provided an analysis of the BRE's reconstruction of the initial fire, which occurred at Grenfell Tower in flat 16. And if we could just go to that, that's at MET 30 40237. there we have it. It's dated the 24th of May 2019. We can see it's called the Grenfell Tower Fire Investigation Reconstruction. And is that the large-scale reconstruction you're referring to in your report?
Yes.
Now, I need to ask you this because when the Phase 1 report was prepared, we didn't have the benefit of your views on this reconstruction. You'd given evidence already, for example, about the extent to which, or the methods by which flame exited flat 16 and entered the cladding. But can you confirm this, that in your opinion, the fire which was delivered in this reconstruction was a very different fire event from the one seen in flat 16, including the fact that this fire attained flashover, unlike the flat 16 fire?
That's correct.
And is it your view that hence this reconstruction, and that's just one reason you give, but it's a big reason you give, this reconstruction does not provide any information which would contradict the views you expressed in your Phase 1 report, or indeed the views expressed by the chairman in his Phase 1 report?
That is correct.
And just to confirm, do any of the observations or measurements that the BRE took during this reconstruction change any of the views you expressed in your Phase 1 report?
No, they don't change anything.
Okay, thank you. Now, you've also discussed other research activities in the appendices to your report. I just want to go to that briefly. If we could look at page 185 of your report, JTOR 706, page 185. So this is where you analyse what research was available on aspects of facade fires prior to the Grenfell Tower fire. And at the bottom, paragraph A23, you say, if we pick it up in the bit in bold, you say, it is therefore clear that prior to the Grenfell Tower fire, the scientific community was not delivering significant and useful information that was capable of supporting a fire-safe design of facade systems such as that which was implemented at Grenfell Tower. And then over the page, you say this. You say, a different issue is the one of awareness. And you say the fire safety engineering scientific community globally was aware of the external facade fire typology, but nevertheless was incapable of securing the support necessary to conduct the research required to quantify the fire performance of facade systems. So can you just help us with this? Why was it, if there was knowledge of these external wall fire typologies, why was it that the fire safety engineering community, in your view, was incapable of securing the support necessary to conduct the research required to quantify the fire performance of these systems?
I mean, the unfortunate thing is that for researchers to be able to conduct research and provide information, you always need funding. And funding has to come from somewhere. Government was much more interested in supporting things that were more targeted in the direction of the reduction of energy consumption and so forth. And the goals of sustainability were very, very strong in the period. And anything that was perceived as being a decelerator to that direction was considered as unwelcomed research, and clearly this falls very much in that category. So governments were not funding research in this area at all, and industries that were actually expanding their market on the basis of the reduction of energy consumption, again, they will look upon this type of research in a very negative way, and in many cases actively opposing it. So people will not fund this work, and whenever this work was done, even if it was done independently, you will get very rapidly reactions from multiple stakeholders trying to quench any information that could come out.
And has anything changed in that regard since the Grenfell Tower fire?
No.
That's still the space that academics...
It's exactly the same.
Right. That's still the space that academics are operating in?
Yes.
And in your view, is there a real need for research to be carried out into the quantification of the fire performance of these facade systems?
I mean, I do hope that there is, if, with my presentation, I really do hope that if there's one thing I have convinced you is that this is an incredibly complicated problem. I think I did manage to confuse you completely with my equations and so forth. And it is a very, very complicated problem that we actually know very little, and that it has massive implications on numerous sectors and in the relationships between different areas of competency and overall in the construction industry. I think it is a fundamental area that requires an enormous amount of work if we really are going to come up with properly optimized systems that are going to meet all the functionalities, including the functionality of fire safety.
Yeah. I've just got one more topic before we look at your conclusions from your report. And this topic is about post-Grenfell modelling related studies. Now, it's right, isn't it, that there's been certain modelling studies conducted after the Grenfell Tower fire, and one such programme of tests and modelling was conducted by Effectis and published in a series of papers between 2019 and 2020, is that right?
Yes.
And you've provided some analysis of these in an appendix to your report, Appendix A2.
Yes.
Let's just look at the first paper that was published. This is at INQ 14908. That was the first paper. It was a study of fire behaviour of facade mock-ups equipped with aluminium composite material-based claddings using intermediate-scale test method. And that was published by the Fire and Materials Journal in 2018. And the work was a series of tests and modelling which you say followed a building block approach and which aimed to give some validation at each stage of the process. Can you just explain what you mean by that?
Yes, the model that they use is a complex computational fluid dynamics model called the fire dynamic simulator, which is a state of the art. This particular model uses a numerical scheme that is called large eddy simulation that breaks the domain in blocks that are significantly large. So you don't resolve the equation for every point. You basically take a block, and then you resolve everything for that big block, and then you have to move to the next one, and the next one, and the next one. And those blocks can be in a smaller scale space, can be 5 centimeters by 5 centimeters. But if you want to mock up or create a model of Grenfell Tower, those blocks become 1 meter by 1 meter. So what you need to do is try to find ways of resolving what is happening in the smaller blocks. And for that purpose, then you have to start with a smaller experiment, a simpler experiment, try to characterize what is happening in this small block. So then you can use that and put it in the bigger block. And that calibration or that information then gets transferred block by block by block. So they started with something that was quite simple, quite small. They moved to the next level, the next level, the next level, until they finally tried to model Grenfell.
And I'll come to some more detailed questions about this modelling, but in your opinion, how useful is this kind of modelling in terms of an accurate prediction of external fire spread?
Well, as the authors recognize in multiple places, it depends what you're looking at. So if I want to get a sense of how the fire propagated around the building, after doing all these calibrations, then I have more or less all the velocities right. And therefore I can see visually how the flame is moving around. Now, if for example, I want to try to understand the failure modes, and look at the experiments that Professor Bisbee did, then I will have to go many scales below to be able to refine and see when the aluminum plate splits. Their starting point is already an order of magnitude bigger of a scale. So they have to make a lot of assumptions about how the aluminum composite panel works. So, for example, one of the assumptions that they make is that they don't look at the failure mode and the split, but what they assume is when certain conditions are attained, the aluminum and the polyethylene disappear. So they basically, the protection of the aluminum is gone and the polyethylene burns. And so, for example, phenomena such as dripping and melting and the burning that happens underneath cannot be predicted, and the whole process of splitting of the aluminum plate cannot be predicted. So they obviously, once everything has split and the fire has gone into their fast growth phase, then they can calibrate, and they are at a scale in which their model is actually predicting quite correctly what is happening in the rest of the building. So the adequacy of the model is more about what you want to get out of it. And the model is perfectly adequate for very large-scale macroscopic type of observations, but it doesn't have the resolution to go into the real details of, for example, all the early stages, of the failure modes.
Yeah. Now, as we've discussed, there are a series of papers that built up, and then there were 4 final papers directly about Grenfell Tower. The first paper was about an analysis of the images and some hypotheses. The second paper uses modelling software to explore different possible scenarios that you described in your Phase 1 report. The third paper attempted to model the propagation of the fire on Grenfell Tower. And the fourth and final paper looked at Grenfell lateral flame spread, so different aspects of the Grenfell situation. Is the reason you looked at these in such detail to understand what use could be made of this work and what the limitations are of it?
Well, I think it was the former. I think, in principle, it was very important, given that we were doing this experimental study that I was trying to support Professor Bisbee. It was very important for me, to try to understand to what extent we could use this information in support of what we were doing, I came to the conclusion that while the results that pertain most of the later papers are quite well supported by the earlier papers in this building block approach, they basically coincide very well with all my observations and all the comments that we have made in the Phase 1 report. So I gained confidence that their modeling in many ways did not disagree at all with anything that we were saying. But at the same time, I came to the realization that for the purposes of what we were doing with Professor Bisbee, the model did not have the capacity of being that granularity that was necessary to be able to understand the earlier stages and the contributions of the different materials.
Yes. So is this a fair summary that you concluded that this work was broadly consistent with your conclusions in Phase 1 and indeed with the chairman's conclusions in his Phase 1 report, but that you concluded that the tests and models couldn't answer the detailed questions which you and Professor Bisbee were seeking to understand as part of the Edinburgh experiments?
That is correct.
Yeah. And was it your view that this work couldn't properly explore the role of encapsulation of the products and how failure of encapsulation might occur?
Yes, that is one of the key limitations of this model, and that it doesn't really have the capacity to understand the failure of encapsulation. It basically mimics encapsulation by trying to model it in a simpler way, but it doesn't look at all into the failure of it, because it just disappears, the encapsulation, when it's necessary.
Yes. Now, I think since you produced your report, you've been provided with some further work and data from Effectis, and I just want to ask you some brief questions about that. If we go back to your report at JTOR 706, page 195, I want to look at paragraph A2.37. So here you say, it's right at the bottom of the page, the test utilises a gas line burner as an ignition source. This particular burner provides a heat flux to the facade assembly. The facade assembly is placed 250 millimetres, and if we go over the page, above the surface of the burner. The heat flux imposed by the burner on the facade system is not characterised, and therefore it is not possible to establish the heat flux distribution imposed by the burner on the facade assembly. Now, would you accept that the heat flux from the burner in the intermediate scale test, ISO 13785-139, has been characterised by a test on plasterboard in subsequent data?
Yes, I think that is something that the authors actually touch in one of their own papers. So this is a standard test, and as such, the ignition source has been characterized in the past using plasterboard as a substrate and extrapolating out the heat fluxes. So I'm perfectly aware of that. But as the author state, there are a series of variations that were done in this test that changes slightly the geometry of the burner, which has a tendency to change the heat flux distribution in a certain way. And also the presence of the facade in itself does have a completely different thermal boundary conditions, so it actually changes potentially the values of the heat flux imposed by the burner to the surface. Now, for me to be able to understand, again, I go back to what are you using the model for me to be able to understand the failure modes, which is what we were looking for, this information is critical. While for the authors of the paper, because they were looking more at the spread later on, and they are not looking at these failure modes, then this becomes almost insignificant. And I actually touch upon that a little bit later when I say that once you are past a certain distance, then it just doesn't matter. And for that purpose then, my comment in A237 then becomes meaningless. So I think many times when we get to this level of detail, things are actually not disagreements, but they are just simply coming from different angles, might be perceived as disagreements.
Yes.
And I think this is exactly one of those cases where I think we know exactly what we're talking about. It's just that we're focusing on different things.
Yes. Now, in terms of the two papers on computer modelling from 2019, there were two papers. One was called The Numerical Simulation of Fire Behaviour of Facade Equipped with Aluminium Composite Material-Based Claddings, Model Validation at Intermediate Scale. That was June 19. And then another with the same title, but Model Validation at Large Scale, was dated August 2019. Now, the papers themselves do not provide the numerical modelling that was used for that computer modelling, but I think you've now been provided with further details of that model. Is that correct?
Yes.
Do you agree that the effective numerical model does take account of the properties of both the aluminium layers encapsulating the polyethylene core of the ACM for the heat conduction, convection and radiation?
Yeah, that's again, we go back to exactly the same thing. If I am looking into the failure mode, which is the way I presented this in my report, I need to be able to resolve the heat transfer between the aluminum and the polyethylene. And for that, I need to refine the calculation to the dimension of the thickness of the plate. Now, they take into account the thermal properties, as they say, but they take them into account as a bulk, because what they're doing is they're heating the bulk of the aluminum and then disappearing it. So for the purposes of what they're doing, of course, they're taking into account, they have to take into account the properties of the aluminum in their modeling. But for the purposes of what we're looking for, it is not sufficient resolution, and it's not the way in which we will have to take into account this to be able to look into the failure mode. So again, I think we completely agree. And in this, and the information that they provided just confirmed what I already knew. It's just that we're coming from different angles.
So it doesn't change any of the views you've expressed in your report?
Oh, no, not at all.
No. If we look at page 208 of your report, at paragraph A287, this is where you're still dealing with these papers, and you say this. You say, nevertheless, this information, even if treated in a qualitative manner, is interesting and useful and shows that these two specific features can serve to enhance the rate of vertical fire spread. And then you say this, the observations that cavity barriers will have little impact on the fire spread rate is also in agreement with the descriptions presented in my phase 1 report. The overall vertical fire spread rates are consistent with those reported in the phase 1 report. Now, based on the numerical data that you've now seen, do you agree that that numerical modelling shows that the cavity barriers delayed the initial propagation of the fire by about 7 minutes?
Well, that is difficult to agree with, because I think in point A287, basically what we're seeing is that the modeling at that scale very rapidly shows that that the flame basically is bypassing the cavity barriers. So it really has very little impact, and therefore there is consistency between what I discussed in my phase 1 report and the modeling. Now, in their modeling results, effectively, yes, the cavity barriers delay the propagation by 7 minutes, or the number that they specify. But that is under the assumptions and simplifications that they have made, because if you, again, go back to this idea of the building blocks, they cannot resolve the cavity. So they cannot resolve the flow field in the cavity. They cannot resolve the gaps in the cavity barriers. None of these things are resolved. So if you caveat what they're saying with based on the coarseness of the model, and there is an estimate of, from a qualitative perspective, I cannot disagree with it. But the model really is not telling you that, in the sense that the model is too coarse to be able to attain that level of precision.
Okay. Thank you. Mr. Chairman, just one more question on this numerical modelling, if I may, and then I finish the topic.
All right.
If we could go to INQ 14909, this is the numerical simulation model validation at intermediate scale, and it's about the performance of cladding systems incorporating different types of insulation behind the PE cord ACM. Do you agree that the nature and rate of flame spread on cladding systems incorporating foil-faced PIR and foil-faced phenolic and unfaced mineral fibre insulation in all cases with PE cord ACM rain screens have found to be comparable in modelling?
At that scale, once everything has taken off, and I think that's actually consistent with Professor Bisbee's observations. So once it's taken off, there's no reason for me to disagree with that.
Yeah. And just briefly, is there a role for these kind of CFD models as part of assessing facade fire performance?
Of course. I mean, the CFD model provides an enormous amount of information, but we have to recognize that CFD models are also quite limited, because we do have to do a lot of playing around with them to get them to work appropriately. So I think in the hands of a very competent individual, they can actually help understand certain things. And so I think that CFD obviously has a very significant value, but it has to be used in a very cautious way.
Okay, thank you. Thank you. I'm sorry for going slightly over, but it's good to get that topic finished.
Good, thank you. Well, I think it's time we break for lunch,
Thank you.
Professor Torero. So we'll stop there. We'll resume, please, at 2:05. And again, please don't talk about your evidence while you're out of the room.
Okay.
All right, thank you. Thank you very much. 2:05.
Thank you.
Thank you.